Hey everyone, and welcome to another video. If you're watching this, you've probably seen a chemistry or physics problem that says apply the general gas law to find a solution, but what does applying a law actually mean? In science, applying a law is just using a mathematical rulebook to predict how a gas will behave when we change its environment. Today, we're going to be mastering the general gas law, also known as the combined gas law, and I'm going to show you a three-step system to solve any problem perfectly. Um, the the general gas law combines Boyle's, Charles, and Gay-Lussac's law into one mega formula, which is called the combined gas law. And you can take a pause and read, but yeah, we move on. This is the formula: P1 V1 over T1 equals P2 V2 over T2. P is in P equals pressure, V equals volume, T equals temperature. 1 is the initial starting conditions, and 2 is the final ending conditions. You could take a pause and read if you want. We're going to be trying a problem right now, and the problem states a 2.0 liter balloon at 1.0 atmosphere and 300 Kelvin is squeezed to a 1.0 liter and heated to 400 Kelvin. What is the new pressure? So we need to find a new pressure. So we find our values first, the initial slash starting conditions, which are 2.0, which is the volume, the initial volume, the 1.0 atmosphere, which is the initial pressure, and 300 Kelvin, which is the initial temperature. And our ending conditions are 1.0, which is the volume in liters, and 400 Kelvin is our ending and final temperature, which is 400 Kelvin. We need to find the new pressure, which is our unknown, so we're going to be using the formula to find that. And this is our table with the data that I just stated. And you have to note, you cannot use Kelvin in this formula. You cannot use Celsius, my bad. You can't use Celsius in this because you must always convert Celsius to Kelvin when doing this. The formula is below there, C plus 273, because the math will fail. Because gas laws are based on absolute zero. So if you want to take a pause, read, check the example below, we move on. The application, we move and shift. See, we move V2 to the denominator side and T2 to the numerator side, and we isolate P2 so that we solve this easier. And this is our formula now. It's V2 times P1 times V1, and then T2 times T1. So now we plug in the values: 1.0 times 2.0 times 400 divided by 300 and 1.0, which will give us our new one, P2. And then the next step is so easy, we're almost there. You might be wondering, what's next? So, this next step might seem, you might think it's complicated, but it's actually super easy. Just take out your calculator and do the following. Step 1, we focus on the top row. The first thing to do is multiply all the numbers on top of the line together. 1.0 times 2.0 equals 2.0, and then 2.0 times 400 equals 800. That's the numerator. So our current numerator is 800. And the second step is focusing on the bottom row, which is the denominator. And we're going to be timesing that to 1.0 times 300, which is just 300. So we simplify the fraction in step 3, and then it'll be 800 divided by 300, which we could simplify, and it'll be 8 divided by 3 because we cancel out two zeros. And to find the final value, we divide 8 by 3 to get the value of P2, and then later we get 2.67, which is our final answer. We use this around all the time in the world, and there's many examples like submarines, astronauts, and so much other things. You can research if you want. But to recap, here's we apply the general gas law. You identify the ones and the twos. You convert every temperature to Kelvin, and you use algebra to solve for x. It's a three-step process that works every time. So if this video helped, if this video helped you wrap your head around this, click that like button and subscribe for more chemistry breakdowns. Thank you. Bye.